Okay, let me see, get the timer started. Today we're going to give you a little lecture about level 3 conversions. All right, level 3. Now, the thing that I want to point out is that one of the most important concepts that you will need to remember is the whole idea of, I'll refer to it as diagonality. You have to be sure that units that are going to be canceling are diagonal from each other. Now, the other thing that could get thrown in here that you have to be comfortable with is, oops, I'm not editing that, exponents, and how to deal with them. So the first thing that I'm going to do is give you a quick overview of what are the different style of level 3 units, like what do they look like based on fundamental units. And then there is a level 3 worksheet, and what I would like to do, depending on my time availability, is simply go through the setups of 2 or 3 of them of the different styles so that you can see how they are put together. Okay, so here are possible structures. Okay, now the first way that we could go to a level 3 unit, derived unit, is by taking 3 separate fundamental units and somehow combining them. So if that's what we have, one possibility is by having fundamental unit A times B in the numerator over C. Another possibility is just having A on top and then having B times C on the bottom. Okay, so that's one possible configuration. Now another one is by having A being squared or cubed over B, or A over B being squared or cubed. The other two possibilities are A being squared or cubed times B, or A times B being squared or cubed. Okay, so these are the different possible structures that I consider to be a level 2 type of, or level 3, excuse me, type difficulty. All right, so I'm going to erase this now, and then what we're going to do is we're just going to dive in and try and do 2 or 3 that might give you a little bit of an exposure to this, and hopefully by looking at them, you'll realize these were the same rules that I learned for level 1 and level 2. It's just that they're all kind of put together in one problem now. Okay, so let me erase this. All right, I'm going to get rid of this. All right, so your assignment is going to be to do the odd ones. So I'm going to start with number 2, which is 2.64 e negative 3, and then we have centiliters over pounds times double H, which would stand for hecto-hours. And what we would like to do is we would like to convert this to quarts over megagrams times seconds. Now I'm going to hurry and make sure that we can see the whole problem here so I have an idea. Oh my God, I really could have gone over further to the left. That's okay. So the thing to remember, all right, I told you I'm not editing this. So I'm going to do something to hopefully color code this and make it even nicer. We got pounds. What are we going to? Megagrams. And then we have hecto-hours to seconds. All right? You're going to have to bear with me because I'm going to be changing colors quite often here. Okay, so if we go ahead, and I'm going to throw things in a tizzy here, because I'm going to start with the red conversion from pounds to megagrams. Now, if I want to convert pounds, remember it has to be diagonal, so that means pounds is going to have to go up here. Now, in order to get to megagrams, probably the simplest thing is to just convert this to grams so that these guys cancel, but then I need to do one more to go from grams to megagrams, and then these grams would cancel. Now that would be my conversion for pounds to megagrams. Now I'm going to go ahead and do the green. I'm going to go from hecto-hours to seconds. So again, hecto-hours is starting in the denominator, so that means it would have to be in the numerator here, and probably the simplest thing to change that to would be to hours, and then I would need to go from hours to seconds. So the hecto-hours cancel each other, and then the hours cancel each other, and I'm left with seconds. Now in the last ones, this is where many of you probably would have started with this one because it was on top. That's why I just kind of did it in a different order. We're going to do centiliters to quarts. So the easiest thing to start with is to go from centiliters to liters, but centiliters is in the numerator, so that means it would have to be in the denominator here. So remember, looking at the red diagonals, they went like this to cancel, but this black one for centiliters is going to have to go this way. So the diagonal is different, but the one thing it still is diagonal. So we're going to go from centiliters to liters, and then we will go from liters to quarts. So the centiliters cancel, and then the liters cancel, and now we have our quarts left over. We have our seconds left over, and we have our megagrams left over. Now the only thing left to do is put the right values in, and remember some of these, rock solid, they have to be certain values now that we've declared them. Others, you might have an option of a couple different conversion factors. So this pound to gram one, probably you'd have to look it up. 1 pound is 454 grams. Mega and gram, this is one of our metric prefix things. So mega, we think 6, gram base unit 0. Mega is bigger than gram, so mega gets the 1, gram gets the E, and 0 and 6 are 6 apart, so this is a positive 6. Okay, green conversion now, hecto-hours to seconds. This is a metric conversion. When we think hecto, we think positive 2. Hour is a base unit, is 0. So the bigger of the two is the hecto-hour. It gets the 1. Hour gets the E. 0 and 2 are 2 apart. So that goes as a positive 2. Hour to second. Some people are more comfortable going hours to minutes and then minutes to seconds. But in your conversion factor, because we'll do this fairly often, I would encourage you to remember 1 hour is 3,600 seconds. And then in this last one, centiliters to liters. Centiliter is this is one of those metric prefix conversions. Centi, we think -2. Liter, base unit, we think 0. Liter is bigger than centiliter, so liter gets the 1. Centiliter gets the E. 0 and -2 are 2 apart, so that's a positive 2. And then finally, quarts to liters. This one you would just look up on your conversion factor document, or you'd have it committed to memory. The one that people used in class is 1 quart is 0.946 liters. So now you have all of the numbers put in place. The only thing left to do is to carry out the calculation. And I'm going to leave that part of the problem to you. I did run out a little bit space there to actually give you room for an answer. But when you actually go to calculate that and give it a try, you will see what the answer is on the worksheet, and you can see if you came up with the correct answer. Okay, so after number 2, we will look at, let's see, let's look at number 4. We're going to do, I think we're going to be able to squeeze in 3 of these. And let me make sure. 8 is multiplication, 6 is multiplication. Yeah, so what we have is 5.72 e negative 1, and we have megaquarts over decameters squared. And what we want, oh, darn it. All right, you got to forgive me on this one. I'm brain farting. Let's see, we'll just go with red, black and red on this one. Instead of the decameters, we'll put that one in red. And what we want to convert to is liters over miles squared. Liters over miles squared. Okay, now before you get going, you can already start to think, what are the steps that I want to take to go from megaquarts to liters, and then from decameters squared to miles squared. But remember, you can only operate on one thing at a time. And so hopefully I was able to emphasize that with the color coding, that when we were doing the red stuff, we were actually not worried about the black or the green. And once we finished with the red, we transitioned to the green and didn't worry about the red and black and so forth. So remember, you can't do this all at once. You just got to be patient and do it one at a time. So if we were going to go ahead and set this up, let's do this traditional way. Most people would go with the megaquart thing first, and they'd go, I think the first thing I would do is go from megaquarts to quarts. Remember diagonality. And then we would go from quarts to liters. And then the quarts would cancel, and we have our liters, which we want for our answer. Then we would come back and do our decameter squared to mile squared. Now here, I'm going to do something a little bit different. I think most people would say, well, I'll go from decameter to meter, and then meter to feet, and then feet to mile. But this is where I'm going to show you that, or remind you, that if you can go between 2 metric prefixes. One of them doesn't have to be a base unit, and it might actually be helpful. Because if we could go from a decameter to a kilometer, then what we would be able to do using the conversion factor on your sheet is we could go from kilometers to miles, and then we'd only have to do it in 2 steps. Whereas if we went from decameters to meters, then we'd have to go meters to feet, and then we'd have to go feet to miles, and that would be 3 steps. So this actually cuts down on a little bit of work here. Now, in order to keep in mind here, decameter is being squared, and so this step would have to be done twice. And since this one would have to be done twice, this one would also have to be done twice. So when we go back to do the calculation, we'd have to keep in mind that we're going to have to do some squaring. Okay, now, when we go back to put in numbers, first magic H here is our metric prefix. We think of +6 when we think mega. Quart is a base unit, so that's 0. Mega is bigger than a base unit, so we have 1 and E. And 0 and 6 are 6 spaces apart, so we get a +6. Liters to quarts, that is one of the memorized English metric conversion factors. This time I'm going to give you a slightly different one. Instead of using 1 quart is 0.946 liters like we did there. The flip side of that one is if you said 1 liter is 1.06 quarts. Mathematically, they're not going to be exactly the same thing, but they are both considered acceptable there. Now we're coming to the red part. Okay, this is where we're doing our metric prefix again. Deca, we think +1. Kilo, we think +3. So between a deca something and a kilo something, the kilo something is bigger, so it gets the 1, and the other side gets the E, and 1 and 3 are 2 spaces apart on the number line, so that would become an E2. Now keep in mind that when we go to calculate, this particular step is going to have to be squared because the unit that we started with was squared. And now on this last one, kilometer to mile, this is one of the English to metric units that you would have to get from your conversion factor chart. And I'm just going to go, let's go ahead and say 1 mile is 1.61 kilometers. Okay? Now this problem is set up and it's ready to be calculated. But remember, one of the new things here is that some steps are to the first power and some steps are squared. And so as a result of that, you'll have to keep that in mind as you process your calculation so you can practice this one just to see if you can get the right answer on your calculator. Okay, last one here. We are going to try number 8. So, number 8, we have, let's see, I'll go ahead and start the number in black. 9.31 E3, and now we'll transition to colors. This time we'll do blue and orange because we haven't used those. We have grams times, and then we have a capital M and IN, and this is cubed. Okay? So, again, remember, MIN, most people, if they haven't had to worry about units before, would be saying, oh, that's minutes. It's not minutes. This IN is inches, and the capital M is mega. Okay, so, and we want to go to, let's see, what's our finishing units? It's hectopounds. Wow, this is really good with all these colors. And meters cubed. All right, so let's get to it. We'll go traditional here. Start with the front unit, which most people would. So we have to get from grams to hectopounds, and so different people are going to do different things here, but I think the simplest thing, if you look at your conversion factor sheet, is to go from grams to pounds and then pounds to hectopounds, because we can do that in 2. So we'd have grams here, pounds here, and then our next one would take us from pounds to hectopounds. So the grams would cancel diagonally there, and the 2 pounds would cancel, and that would leave us with our hectopounds. Okay? Now from here, we're ready to transition to our mega inches. Now when we get to this, I don't see a super easy way to get from mega inches to meters in 2. So maybe what we'll do is we definitely have to have mega inches here, and we're going to have to go to inches here. And I think some people might recognize, ooh, I could go inches to centimeters and then centimeters to meters. I'm not sure most people would gravitate to that. I think more people would see, I can always go from inches to feet and then from feet to meters. Okay? But keep in mind that this unit of mega inches is being cubed, which means every single one of these steps has to be done 3 times. And we have mega inches, diagonal, inches then diagonal, feet then diagonal, and we're left with our meter, and it's cubed, and that would give us our answer. So now what we have to do is go back and put in our values. This we used up here. 1 pound is 454 grams. Hecto and pounds. Hecto, we think +2. Pounds is a base unit, we think 0. Hecto is bigger than that because it's got a bigger number. That means it gets the 1 and the other side gets the E. They are 2 apart from each other, and there we have that in there correctly. Now we can go to the mega inches to meter part. Mega, we think +6. Inches a base unit, we think 0. Mega is bigger than a base unit, so it gets the 1. This gets the E, 0 to 6, 6 spaces apart. There's our 6. Feet, inches, 1 foot is 12 inches. That one you should know. And then finally, meters to feet. This one you have 2 possibilities that I've given you on the conversion factor sheet. What I'm going to do is I'm going to use the one where the 1 goes with the foot, which means 0.305 goes with the meter. So at this point, you can go ahead and calculate your answer because everything has been set up properly. So I'm encouraging you guys, since I set all this up, just take a moment, go through the calculations, and see if you get the right answers that are on the level 3 worksheet. And then your assignment is going to be to go ahead and do the odd problems. So that's 1, 3, 5, 7, the 5 odd ones on this worksheet. And if you feel comfortable doing these, you are definitely in a good spot for anything I could give you. There are further level difficulties, but that is just by adding in extra exponents into structures that look like this. So if you can handle exponents, you can remember to put everything diagonal. I am not sure there is a problem you can't solve, assuming that you can do the calculation properly on your calculator to get the right answer. All right, so hopefully that was helpful. Went a little over 20 minutes, sorry about that, but this is the only video you got to watch this time, and you got work to do. So good luck, and if you have any questions, remember, get in touch with me.